Have you ever wondered why our body can process a morning coffee perfectly fine, but a heavy night of drinking leaves you feeling awful for hours? It all comes down to how our body clears drugs from the system. In pharmacology, this is governed by two entirely different sets of rules: first order kinetics and zero order kinetics. Most drugs follow first order kinetics. They are predictable, well behaved, and adapt to how much you take. But a few notorious substances like alcohol switch over to zero order kinetics. When that happens, the body's clearance system gets completely overwhelmed. Let's break down exactly why this happens using a simple factory analogy. Let's start with first order kinetics. This is the standard rule for 95% of drugs. Imagine a factory conveyor belt bringing drug molecules to an enzyme worker. In first order kinetics, a constant fraction or percentage of the drug is eliminated per unit of time. Let's say that fraction is 50% every hour. If you have 100 milligrams of a drug in your system, the body clears 50% in the first hour. So 50 milligrams is gone. In the next hour, it clears 50% of what's left. So 25 milligrams is gone. Notice what's happening here. As the concentration of the drug goes up, the rate of elimination goes up too. The more you take, the harder the enzymes work. Because a constant percentage is cleared, the graph of drug concentration over time shows a smooth, exponential curve. This is why drugs under first order kinetics have a predictable half life. The time it takes for the plasma concentration to drop by half is always the same, no matter how much drug is in the body. Now let's look at the exception: zero order kinetics. This happens when you flood the body with a drug and the amount of drug completely vastly exceeds the number of available enzymes. The system becomes saturated. Think back to the factory. If you throw 1000 molecules at the workers, but they can physically only process 10 molecules per hour, they work at their maximum capacity. It doesn't matter if you add 1000 more molecules, the workers cannot go any faster. In zero order kinetics, a constant amount of drug is eliminated per unit of time, not a constant percentage. If your body can only clear 10 milligrams of alcohol an hour, it clears 10 milligrams whether you have a blood alcohol level of 50 or 500. Because the clearance rate is fixed, the graph isn't a curve. It's a straight, linear downward line. And here is the kicker for exams. Zero order kinetics does not have a constant half life. The time it takes to lose half the drug changes depending on where you start, making toxicity highly unpredictable. To make sure you ace this on your next exam, let's pin down the key differences side by side. First, the elimination rate. First order is a constant percentage that is proportional to concentration, while zero order is a constant amount that is completely independent of concentration. Second, the half life. First order is constant, but zero order is variable and gets prolonged at high doses. Third, enzyme saturation. Enzymes are not saturated in first order, but they hit their maximum capacity and become completely saturated in zero order. Fourth, the graph shape. First order gives you an exponential curve, while zero order gives you a linear straight line. Finally, the examples. Most drugs like metoprolol follow first order, but you can remember the classic zero order exceptions with the easy mnemonic: PEA, phenytoin, ethanol, and aspirin at high toxic doses. These drugs easily saturate their metabolic pathways, turning into dangerous zero order wildcards. Understand the difference between a constant percentage and a constant amount, and you have mastered rate kinetics. See you in the next video.